Hello, Professor. The theme of the course design I choose this term is the Private Guide, Machine Learning with TensorFlow. I'm Pan Xu, and my team member is Ma Ruihan. Today, we are trying to leverage machine learning in many aspects of modern life, yet many of our most impactful application of machine learning is healthcare, transportation, and flights are blocked because they are re- they are require access to sensitive data. In this course design, I use TF interpretation and Python's secret fets to train and deploy machine learning models in the cloud using remote execution, secret federated learning, and encrypted prediction while protecting the price of model and end user input data. TF interpreted is a framework for encrypted machine learning in TensorFlow. It looks and feels like TensorFlow, leveraging the ease of use of the Keras API while training and predicting on attributed data via secret multiply parts computation and complicated interpretation. TF attribute aims to make private pricing machine learning readily available without requiring expertise in cryptic photos, distributed system, or high-performance computing. Then first, I will introduce the rent-code introduction. The basic of the artificial intelligence accuracy of model is that, and the accuracy of model depends on the quality and combination of the data, combining the data of the world industry and carrying out model training based on massive multiple dimensional data can effectively improve the accuracy of the model and help individuals in the industry gain great benefits from the evolution and breakthrough of artificial intelligence algorithms. However, due to consideration of commercial confidence and data integrity, embedded data segregation has become a constraint to realize joint model training. The multi-part segregated computing technology enables the data of all parts to performance global brave calculation in form of secret text, and its ability ensure that data is available and invisible make joint model training among the industry possible. The API we use and the rand map, the OR rand map is proposed on the left, and the advantage of the API have three advantages. The first is high-level APIs for combining privacy and machine learning. So for TF attributed is focused on its low-level inference, but it's time to figure out what it means for the inference, such as curious when private enters the picture. And the second is Tiger integration with TensorFlow. This includes Elegant with the oncoming TensorFlow 2.0, as well as figuring out how TensorFlow and Qpid can work closely together with related projects such as TensorFlow Privacy and TensorFlow Federated. This is all for Privacy Guide. The last is support for the third-party libraries. This I think is very important and where for the researchers, where TensorFlow Interpret has its own implements of the secret computation. There are other excellent libraries out there for both secret computation and home-protected attribution. We want to bring this on board and provide a bridge from the TensorFlow. And many use the TensorFlow API interference in Greenblock. In Greenblock, this is we use for the or experiment Then I will introduce the technology description. Multi-part secret computing refers to the calculation of an object function by multiply participants in the absence of a trusted third part, and ensure that each part only obtains its own calculation results and cannot infer any other parts through the interactive data in the calculation protects input data. And machine learning and deep learning usually bring high computing cost. This is very hard for the researchers to solve. So how to meet the real-world performance requirements under a fixed security model is very much. As the second page I said, I use the TensorFlow Entropy MPC API. So what is MPC? MPC is applied to high real-time scenarios and large-scale natural network training, makes the prediction possible. It have two advantages. The first is ergonomy optimization, several times to improve the exciting network training. This will serve a lot of time for the researchers. For example, a big team will get the results under two numbers, but individual researchers will spend 2 days to get the results. If we use this MPC API, the time will serve for the individual researchers. And the second is hardware acceleration. This means support the use of GPU and other devices to accelerate MPC calculation by terms of the time. And the third advantage is as I show the picture on the left, this is an example of a medial application. Compare with the processing of traditional medial transmission. Multiple part secret computing generate the privacy and security of each other. For example, assume that both Chengdu National University Hospital and Dachshund Hospital need to process medical related data. Based on traditional methods, both hospitals can see the data uploaded by each other. If the data leak occurs, they can even see the training data image results. This is very wrong for the researchers to leak the data. But based on the current use model, even though both hospitals are training on the same cloud server platform, they do not know each other's news and can only receive the results of their own training. Then I will introduce the detailed agreement. The core agreement is divided into 6 parts, which I will introduce separately. The first is home peak communication is a graphic protocol that allows an individual to submit a chosen value to other without reliving the value itself. Once submitted, the value cannot be changed, and it can be public version later. Home peak communication enables computing to perform on a committed value while perform the confidently, immediately, and verbally feature of the communication. For example, we can see a lot of symbols in the picture. The first is the C1. C1 means the generated communication value. For example, we have 4 users need to train the network S1, S2, S3, and S4. The C means the S1 sends C1 means the S1 sends the data training for the cloud server platform. C1 means the data value. And S1 means the user sender, as well as the user want to train the called server platform. And G and H is the elliptic creative vehicle a point. This means this core is a point. And R1 is a secret key, and HR1 is a public key, and X is random. This is a blending factor. R is the protector by private information, and C1 is equal to GX1 multiply HR1. Then, if multiply users upload the information to be proposed at the same time, then a complete data chain can be obtained according to the Fluent form. The Fluent mode is C. C is means the data chain. If we have 4 users, the data chain may C may equal to C1 multiply C2 multiply C3 and multiply C4. This is the first step. And the second step is home ticket interpretation. This is a method where each participant encrypts their input and send it correctly to a computing server. The server can perform a computing directly on the CityGraph text and send the results CityGraph and to the designed reception. And the reception then describes the correction to obtain the final computing results. In this way, the computing server operated solely on the certificate and cannot see any meaningful information, while the participant only receive the final results and cannot observe the intermediate results. For example, based on the first step, A is the dataset proposed by the user want to training. Then they will annotate the A means make make select about that. Then A is the original dataset of the sender, and ENCA is the function what the sender make a secret about the dataset. And OP means adaptive operation. Then B is the another original dataset from server another users, and they also do the make secret operation. So AOPB equal to C. C is the data chain. Then also if A B makes select and B select make select, they also get the selected chain. This is the ENCC. This is the second step. Then the third step is secret chaining. The basic idea of the secret chaining is divide that into multiple parts and distribute them to different participants. For example, on the left, the main secret can be divided into n parts. The n means there have n users. Then each participant hold one part. This one part is belong to their own. They cannot get others parts and cooperate to complete computing tasks such as addition and multiplication, because participants cannot see the full amount of data information about the data chain. Data privacy protection is achieved. Then this is the second part step. Then the fourth step is Yaws-Kleber creating practical. The basic idea of the observation critical to interpret and screen each gate of the calculation credit to ensure that the original input and intermediate results will not be leaked during the calculation process. The two parts calculated and described according to their respective inputs in order to obtain the only correct results, and other information other than the results cannot be obtained, so as to realize the secret calculation of both parties. I will introduce the I will list an example to introduce the graphy. For example, the A and B is Alice and Bob. They can each have data X and Y. Compare with the size. On the first step, Alice encrypts and obfuscates the crate and then give the obfuscate table to Bob, so the Bob can get the obfuscate table. Then the two parts used in advanced transmission so that Bob can select the opposition tab through his own input. Finally, Bob can calculate the obfuscate level through the obfuscate the key. The key Alice and Bob can own their own key. They cannot get each other key and decrypt it to get X and Y. And F is means A and B, and R is the result consists of the experiment 0 or 1. This is the fourth step. Then the fifth step is independent transmission. This means observable transfer is previously provision two-part communication protector that enable both parts to send message in a way that obfuscates their choice. The observable transfer protector is a basic protector of cryptography, which enables that the receiver of the servers to obtain certain message input by the sender of the service in an independent way, so that the privacy of the receiver can be protected from being known by the sender. For example, if one sender sends two messages M1 and M0 each time, and the researchers input a choice B each time, the B means he will choose 1 or choose 0. When the agreement ends, F cannot obtain any valuable information about B. So the B is R makes choice. If R only choose obtain M1 and R cannot know the M0. This is the developmental transmission. And the last thing is zero knowledge proof. Zero knowledge proof is the privacy guard principle. This means these have been introduced in early 1980s by Sir Goldwist and other researchers. They refer to a scenario when a proof convinces a user that a certain statement is true without providing any useful information to the user. Zero knowledge proofs are destination protector involve two or more parts, where their parties engage in a series of steps to accomplish a split text. Their proof aims to convince the virtual that they proposed and or know the partly message without revealing any information about the message during the proof process. This is the also over 6 parts about the experiments used a graph chart. Then I will introduce the performance. The first is how to installation. Then we use the TensorFlow and we use the API proposed by the Facebook. The TF interpreted is available as a package on PyPI support by Python and TensorFlow. Then we will use the red sentence to pin the TensorFlow interpreted. And we need to creating a code environment to run TF interpreted code can be done using as the list. Then the last is annotated installed from the source can be done using. This is proposed by the Facebook and the TensorFlow lab. Then the core using agent is the following is an example of the simple mention on the interpreted data using TensorFlow based on TensorFlow 2. You could execute a mention in the integer mode or building a graph by the TensorFlow function. In the experiment, I use this for example, and the training time may for 2 days to get the graph results. And if I have make the code to zip, then I will send it to you, Professor. If you have interesting in the previous guide, you can check out the code zip. Then this is the processing of running the entire code. We can see this is the or non code, and we can and the first thing and then use the command line required to run the code. On the command line, we can see the experimental dataset, evaluation, indirector, and corresponding results. Now we can see the this is the depth and the torch size and the training time. Then this is all the training time. Then finally, we show the results we get. We training for 2 days. This is the result. This is the results image obtained by building a network graph for deep learning. Then the performance results is the results, and the time about we built the graph is on this page. All the tests are performed by the ABY3 protector among 3 machines. So the 3 machines is combined the 1 computer and 2 and 2 card server platform. Each with 4 cores and TensorFlow, Python, and PnP. Then the graph building is a one-time cost. I use 2 days to training the graph, and while the line or one timing arrange running time across multiple runs. For example, it takes 152.5 seconds to build the graph for ResNet 50 models, and after that, it only takes the 19.1 seconds to predict each image. On the left lab, the mixed operation is implemented using a sorting network, so its performance is similar to that of the soft operation. Sorting network can be efficiently constructed as TensorFlow graph. The traditional program of using a binary combination trees to compute the mastermind does not work well in the TensorFlow graph, especially when the number of experiments is large, as this results in a large graph. This means if we choose training the network have been trained before, the training time will be short and get the results for little time. Then the second is this means that there are 2 multiply 10 max cores for 4 experiments, which is effectively a max pro operation with a process of 2.2 multiply 2. This means I find a training size with experiments and get the better choice about process. Then this is all experiment introduction and the performance from the installer training and the code and the training process and the final results. This is all I want to report. Thank you, Professor.